Welcome to another edition of Seiler Design Solutions Tips and Tricks. This is Rob Windsor. This is actually an excerpt from our most recent webinar. Hi, I'm going to talk about Inventor, and I have more than just 5 tips and tricks, mainly because a lot of them are pretty quick and easy. But the first thing I always do with Inventor, I've been using AutoCAD since I was a kid, like middle school. So I'm used to the way AutoCAD works, specifically with the zoom feature. And I always, no matter what software I'm using, I have to figure out how to change the zoom. So I just want to start off with that. It's just as easy as going to File, Options, and on the Display tab, click Reverse Direction in the zoom area. The next thing I want to do is actually just talk about when you first come in, you have to place your sketch on a plane. Default in Inventor is it just says YZ plane, XZ plane, XY plane. And every time I have to place a sketch, I always have to hover over it to find out which one it is before I click on it. So what I did is I renamed my origin sketches. And it's just as renaming an item in Windows, it's the same thing here. Slow, double click, and you can rename the item. Here I actually spaced out, I kept the original name and spaced it out so they all lined up. That was just my preference. I wanted to keep both of them for reference. And then once you get this done, you can go up to File, Save As, and you can do Save Copy as Template. And what I did is I just clicked on the standard IPT template. I saved over it. Click Save. Yes, I want to replace it. And every time I do a new IPT, I always have these new names on the origin planes. The next little step, I guess, is keep this in mind with regards to you can actually set up as many templates as you want. If you have something you're always working with, flanges or say this motor shaft here, you always have a cylinder with, you have to capture the motor. So you've got your snap ring grooves. You have to get it to turn. So you've got your keyway slot. Every motor shaft is going to have these 2 features. They're going to have a specific length on the end for the drive sprocket and then a specific length based on the motor. You can actually put all this stuff into a template. You do your base part file with all your features, and you can do a Save As template. Now, I do want to point out there's a good way and a bad way, and I'm starting off showing I feel the bad way. I feel that you want to have as few features as possible, especially if there's many people that are going to be using this part file, or if you're going to share it, it's the fewer the features, the better. Because right here, I can move the end apart, and let's go back in time. We'll go to where I started this. I've got a cylinder, and then I add the snap ring groove, and then also the end of the shaft, another snap ring groove, and then the drive end. I added a chamfer, and then my keyways. If I need to go in and modify this, I would have to modify each feature, each sketch. That's a lot of clicking. It's a lot of stuff that I don't want to have to go in and modify. So I always try to get everything into as few sketches as possible, as few features as possible. That way it's easier to go back and modify it. With that in mind, I also want to bring back the fact that you can rename things. And I am an advocate for renaming as much as possible. So right here, they're all extrusion 1 through extrusion whatever. You go into the sketch, the default naming of the dimensions start with a D and just sequential numbers. So D1, D14. This one happens to be D14. Doesn't tell you anything. So let's switch over to another configuration. And this is the way I prefer to do it. You have a feature. It's a Revolve feature. This is a part that's going to be turned on a lathe, so you might as well make it that way. So I start with a sketch, and I put everything in one sketch. I named everything. And one thing to keep in mind that while typically when you dimension something, whether it has a name or not, all you're going to see is that number. So down here, you can change it to show just the name, where I'll just see that, but it doesn't show you what dimensions they are. So I switch it to the expression. It's a little bit more info and clutters up the screen, but it shows me what I need to know. Now, with the idea that you have as few sketches, as few features as possible, you also want to have as few dimensions as possible. So I always use construction geometry as often as possible. Here I have a chamfer. It's just a corner break for the shaft. I have a chamfer on both ends, but this other chamfer, there's no dimensions. And all I have is one dimension down here for the chamfer. If you've ever used Inventor, when you put a chamfer in a sketch, it puts two dimensions in there. So it's like two linear dimensions or a dimension and an angle. What I did is I drew this chamfer in as I was sketching this, and then I defined it with, I have two construction lines here underneath my dimension lines. I put equal constraints on them, and then I just use one dimension to rule both of them. Then I come down here, this other chamfer, two construction lines, equal constraint to the other two at the other end. I have one dimension giving me four different dimensions at once. Again, fewer dimensions, use construction geometry. It cleans up your sketches quite a bit and is very helpful, especially if many people are going to be using this. At this point, we have named features and named dimensions. So yes, it's easy to work with at this point, but there's more you can do with it. You notice I have multiple configurations. I can just double click and my shaft changes. And I do this with the iPart. So you would just create iPart, brings this up. And here again, another reason to name your dimensions, name your features. As you can see, my motor shaft has all these dimensions. I know exactly what to bring over to the right side of the screen. These down here, I have no clue what these are. I don't know what that dimension does. So naming things helps further down the line. All of that stuff gets, as you move stuff over to the right side, it adds it to this table down here. These are the columns. And you can set it up. You can right click, insert row, delete row. That adds additional parts to this part file. And so you first set up, you can have your suppression tab, you bring extrusions over, and you can say compute or suppress. That's the main difference between there. I can show you this configuration that I'm using has all of these suppressed at the bottom. And this one shaft bad option, it suppresses the top stuff. Over here, I have the dimension names are the columns. You can come in, you can retype dimensions, and you can make as many parts as you want. Now, if you notice, I have these here, they're red for some reason. I cannot change them. I also wanted to show that you can use an Excel spreadsheet to set these up. Now, like with any table in Excel, you can drag your columns down and it'll autofill, and you can add many different configurations using this table. What I tried to do here is then I put a table down for my keyways. The keyways and the snap ring grooves, they're industry standards. For a 20mm shaft, you have to have a 6mm keyway. So what I did is I have formulas looking at this table. Got a VLOOKUP, and it's driving my dimension in that spreadsheet in the iPart page. But I also want to point out they have a very wonderful iLogic. You can add rules. And to open up the browser, you click this button, but I've got it in my home bar over here. So it uses Visual Basic code, but it thinks the same way like Excel formulas. It's an if-then statement. This one is if my shaft is greater than 6, less than or equal to 8, my key width is 2 millimeters wide. The mill depth is going to be 1.2 millimeters, all the way up to maximum 38 millimeter shaft diameter. Now, the standards go up higher than that, but for this shaft, for this company, that's the largest they ever go. And I even put in a message box, which you can pull from over here. If these don't work, pop up a message box saying, please limit your shaft diameter. You save and run this, and it will, right now it doesn't do anything, but right now, this keyway is 6 millimeters wide, and the shaft is 20 millimeter diameter. So let's change the shaft. I'm changing one dimension. I'm going to change this to 35 millimeters. That's definitely going to take me into the next stage of keyway slot. So it automatically updates the sketch. I finish the sketch, it updates the part file, the model. And if you notice, this keyway automatically updated. It is now 10 millimeters wide and 5 millimeters deep. Those are the main things I wanted to talk about. The benefits of naming your features and your dimensions can be used all the way down the road in making this as automated as possible.